Hello all, hope you're doing well. Uh, Firstly, I'd like to thank Professor Gregory for giving me this opportunity to present my project. Uh, I'll take this opportunity to showcase my project that I've been working for a month now. So my project, the project I chose was the online poker database, which is basically a database to store player statistics who play poker. So I've named it PokerGo for my convenience, uh, and it is basically a complete database which holds the statistics of the players who plays poker. Before starting the discussion on the project or the thing I've done on the project, I'd like to address the problem because the problem is the starting point of any solution. So basically, when a player plays poker, the first thing he does is puts money out of pocket, and without any tracking tool particularly to track that, uh, there's a high chance of losing your money. The player is most likely concerned about two things or two statistics you could use: the money you're getting in and the money you're getting out. But before playing poker, or before you learn poker, the first thing you need to know, and by far the most important thing you need to know, is why you should track your poker results. So in address, well, the thing I've addressed earlier is the problem, and here's the objective of that thing. There are three main objectives or perspectives to address the problem. That is to get an overview of your spending. Second is to gain an objective perspective of your game. And third is to adapt and improve your poker game. So these are the few human queries, you could say, that any basic uh, human can understand. These are the few sample queries that I have used in my project. The first query is to find the name of the players that played on a particular date. That is, if you consider a player uh, named a particular player who has played poker on 3rd of June 2021, that you could basically bring out in the output. And the second query is, what is the most common bet on two aces? So ace is one of the cards or one of the types of the poker cards. So what is the most common bet that the players are placing on the two aces is one of the queries. Then the third query is, which player or the players has the most aggressive style of betting, largest average bet. That is, few players tend to place aggressive bettings, that is large amount of bettings. So that is the third query. And the fourth is, which person has the most bets placed. That is, few players again they place a lot of bets depending on the cards they have. So that is the fourth query. And the final sample query is, which person has won the most games. So in a period of time, a particular person might have won 0 games, few games, or many games. So this query is to gather the most games, the person who has won the most games. So these are the few queries I have used. Again, you could consider these as the sample queries. What I have done here is placed a human query and then showed you the SQL or a MongoDB query that I have used to populate the data. So the first query is to find the names of players that played in the month of October, that is October 19, 2020 tournament. So this is particularly the MySQL query that I've used to populate the names of the players that have played in the October 19, 2020 tournament. Here we are selecting the names from the table called P, where we are joining the person name, ID of that person from the table player again. And we're also joining the tournament and the tournament ID of the player. where we're again considering the date held also as an attribute, where the date held is October 19, 2020. Again, the second query is what is the most common bet on the two aces? Uh, Again, aces is one of the types of cards. So we're selecting select star refers to selecting all of the data that is present in the data set. So we're selecting all the data from amount table, where we're selecting from the bet table all of the data in the bet table, where the cards are two aces, because here we are particularly talking about two aces. We're selecting the aces from all the cards that are present. Again, we are grouping them by amount. Since we are talking about the bet, it is in terms of money. So we're grouping the uh, ace cards with the help of amount, that is the common amount that has been placed on the ace card, where a sub times is max sub times. This statement is for the maximum number of bets placed on that. And the third query is which player has the most aggressive style of betting, that is highest bet, or a person who is continuously placing large amount of bets. So here we are selecting, again, we're selecting all of the data from player ID, where player ID is a primary key. Average amount we're considering from the bet table. We're grouping it together with the help of player ID, which is again, we're taking the average. That is, we're considering average amount placed by the player in terms of few matches that he has played in the recent times, in order to get the average or the largest average bet amount. So this is the schema design that I've placed here, or the table design, you could say. Here, tournament, person, game are a few of the tables or the schemas I've used in the database. All the three, not certainly all the three databases, because the Neo4j doesn't use a schema. It is a graph database, so it has nodes and stuff. But particularly about SQL and or in this case, I've used the relational database, and the MongoDB as well. They take schemas. So talking about the first schema, that is tournament, it has three attributes, namely ID, name, date held. ID is the primary key. So uh, ID is the type of attribute is primary key. Then the name is of string type and date held is of date type. So ID is a primary key. So what primary key is? It is a column or a set of columns in a table whose values uniquely identify a row in the table. That is, it is a unique ID, or because since the ID is always unique, we have referred it to the primary key. Next, the person has two attributes, ID and name. ID again is primary key and the name is string. Talking about the third table, which is game, we have three attributes, ID, tournament ID, and the winner. ID is certainly again primary key since it cannot be duplicated. Tournament ID is a foreign key, and the winner is foreign key. So what foreign key is it is again a column or a set of columns in a table whose values correspond to the values of the primary key in another table. Because tournament ID refers to the tournament, a tournament has certainly persons. So the foreign key is corresponding to the values of the primary key in some other table. So that is how foreign key is different from primary key. So this I've placed the sample query or the connection. Firstly, there's a connection string, this red line, if you can see. This is the Mongo Python file or the Jupyter file, a sample shot of the file. So this is my username, and this certainly is my password that I've used to connect my Mongo with the Atlas. That is my application with the MongoDB Atlas. So again, here are the few queries that I've used. And here are the sample queries again that I have showed you earlier. So what this line is, this is a connection string that you obtain from the MongoDB Atlas, where you input your username and password. This is how you basically connect your MongoDB Atlas with your application. MongoDB also provides an option of connecting the Atlas with the Compass or just the command shell. Since this is an application, we have used the connect with the application thing. This is the Python file or the Jupyter file of the Neo4j database. So the Neo4j database connection is a bit different as that have the Mongo. Certainly, the connection string is certainly similar, but the way you give the username and password are certainly different. Though the connection, since we're mainly implementing the program or implementing the project with Mongo, I've certainly used Mongo. The connection line would be same, but in the coming slide, there would be a clear picture of how I have connected Neo4j with the Neo4j browser. So again, these are the queries that I have used, the sample queries here in the green and the actual queries in the red. So this is how you initiate a Neo4j. This is the username and this is the password that I have obtained from the Neo4j browser. This I have copied and basically pasted here, which helped me connect my application with the Neo4j browser. So this is a kind of the Neo4j graph. This is how Neo4j stores the data, whereas MySQL and MongoDB stores in terms of schema, that is tables. Here, if you consider this is a node. James is a player who has been playing poker now for a while. This is the attribute is person. Uh, he is connected to various nodes again, since this is a graph, or you could say tree. He is connected to several other nodes and stuff. This is the connection, or you could say the link that is to the other nodes. So if you consider a few of the attributes, they show how the player is related to the bettings, the part of the tournaments here, the bets he's placed, and everything stuff. Neo4j is not certainly that simple. If you look at it, it's not that easy to bring out the data, because we've been mostly using MongoDB or MySQL as a matter of fact, but Neo4j is certainly something different. It stores the data in terms of a tree, that is a graph. So this is the main SQL or the relational database file, the connection thing. Again, I've connected it with the MongoDB and made sure I've got the output that I wanted. Again, the similar connection string, similar questions, and the similar queries. So here I've placed a small sample video of my output, that is my application. I'm going to play the video now so that you guys can quickly go through it. So here the first what I've done is check players who have played in that particular date, I've changed the database and I've gone to the second question. Again, change the database now with the Neo4j, now with the SQL. Again, aggressive style of betting in different types of database, and which person has bet the most in the recent times with all of the three databases, and which person has won the most games with the help of all three databases. So basically, that is what I've tried to figure out with this project. So again, the same kind of thing. So coming to the database comparison, I felt I was more comfortable with the MongoDB because it was more flexible and dynamic database that I've worked so far. That is in priorly I've worked with MySQL. This time I worked with SQLite 3, and I've worked with now MongoDB and Neo4j. These are certainly new databases for me. So out of all, I've felt MongoDB has been the most flexible and dynamic database so far. Why MongoDB particularly is that the indexing feature that has really appealed me to easily search the document. In terms of comparison, we all know that Neo4j is no SQL database. So insertion of data was more flexible when you compare it to the relational databases, the traditional relational databases. But one more thing about MongoDB that uh, that impressed me was that it did not create relationships between the database models. In fact, each data set was stored in the database independently. That is how MongoDB is like flexible and dynamic in terms of data storage. These were the few points I felt while working with all of the three databases on certainly extensively working. And one more thing I like understood was that MongoDB stores or shows or represents data in terms of JSON files, whereas relational database stores in terms of tables and rows, the ultimate storage. MongoDB didn't support join, but MySQL certainly supported join operations. These are again few comparisons between MongoDB and the MySQL or SQLite 3, because SQLite 3 used the regular structured query language, that is SQL language, whereas MongoDB used JavaScript as the primary query language. But if you ask me which was easy working with, at least for me, I'm not talking about the other students or the other people around the globe, but at least for me, I thought MongoDB was easy one when compared to MySQL in terms of flexibility. Again, because of the schemaless design of the MongoDB, makes it extremely easy to build and enhance applications over time without needing to run complex and most expensive, what do you call, tables that you have to migrate or transfer as you would do with a relational database. And also why MongoDB I preferred, or in the future I would prefer MongoDB, is it offered me really fast query processing. But yeah, certainly it came with increased load on my system, because while I was using it, my system certainly got a bit slow than what the average speed of the system is. What I suggest or what I do in the future is, for simple use and limited queries, I'd go with use SQL, and if the query processing is high, then I'll certainly go with MongoDB. Why I'm not talking much about Neo4j is that it's a graph database I was not really comfortable working with it because I felt it was very complex because databases could be represented or the data can be processed in a simpler ways. We have simpler ways to do it, but for me, the Neo4j was a bit tough or a bit challenging in the entire project. So it has, yeah, edges and properties and stuff. Uh, it really got to me. Yeah. Yeah, but it's suitable for big data and analytics stuff. But for the regular application project, I don't think we or I would particularly use uh, the Neo4j. I'd certainly go for MySQL if I'm doing a simple queries or limited queries. But if it is uh, again, if it is large data sets or large this thing, then I'm certainly going for the MongoDB. So that's it, I would say, for now. Thank you once again for uh, giving me this opportunity to present my project or the application that I've created. And also thanks in advance for all my classmates for going through this video. And yeah, do not forget to post your questions on Western Online so that we can have a good healthy discussion. And I'll make sure and I'll really make sure that I clear all of your queries in the coming 2 days. So once again, thank you and have a good day all.